Self-exercise at point 2, question 1. A particle moves along a straight line from a fixed point O. Its displacement as meter t seconds after passing through O is given by s equal to 4t squared plus t. Calculate the total distance in meter traveled by A when the times is in between 0 to 4. To find the total distance, we can either use the method drawing a number line or sketching a displacement function graph. So here I'm going to use the graph method to understand the movement of this particle to find its total distance. So this displacement function is a quadratic with A equal to 4, which is greater than 0. Then the shape of the graph will be a small one. And the C is equal to 0, which means this quadratic graph passed through the origin. Next, I'm going to find the root. To do so, I'm going to let s equal to 0. Then this will be 4t squared plus t equal to 0. Using factorization method, it will be t bracket 4t plus 1 equal to 0. From here, we know that t is equal to 0. Another one will be t equal to negative 1 over 4. With all these informations, now we can sketch the displacement time graph. So this will be the graph look like. For this part of the graph, the time is negative. Therefore, we're going to ignore this part. So starting from the origin here onwards, this will represent the movements of the particles. At the origin here, the t is equal to 0 and s is equal to 0. This means when the time is equal to 0, the particles is at the fixed point O. And from the graph, the displacement is always positive. Therefore, the s is greater than 0. This means these particles is moving to the right hand side of the fixed point O without any turning point. Therefore, the total distance will equal to its displacement. For questions A, the range of time here is the same as in the first 4 seconds. Therefore, the total distance, this is equal to s4. So here we're going to substitute t equal to 4 into the displacement function. Then it will be 4 times 4 squared plus 4. This is equal to 64 plus 4, which is equal to 68. Questions B, we're going to find the total distance from t equal to 3 to t equal to 6. So based on the graph, the total distance will be here in between the t equal to 3 to t equal to 6. So first, we're going to find the displacement in the first 3 seconds, which is s3. This will be 4 times 3 squared plus 3, which is equal to 39. Then next, we're going to find the displacement in the first 6 seconds. So this will be 4 times 6 squared plus 6, which will be equal to 150. So to find the total distance in between 3 to 6 seconds, it will be S6 minus S3. So 150 minus 39, which is equal to 111. Question number 2. A particle moves along a straight line and passes through a fixed point O. Its displacement as meter t second after it starts moving is given by s equal to 60 minus t squared plus 7. The particle moves to the right until t equal to 3 and then moves towards O again. Find A, the total distance in meter traveled by the particle first in the first 2 seconds. From these displacement functions, when we substitute t equal to 0 into the displacement functions, then the displacement will be 6 times 0 minus 0 squared plus 7. Then the displacement is equal to 7. This means at the start, the particles is not at the fixed point O, but it is at 7 meters to the right of the fixed point O. So for a displacement function with c is not equal to 0, this means the particles were not at the fixed point O when it started. but it will be at the value of c as the starting point. So from the questions, the particle moved to the right until t equal to 3 and then move to O again. So this means at t equal to 3, the particle is moving in the opposite directions. For questions A1, in the first 2 seconds, the distance will be in between t equal to 0 to t equal to 2. So first we're going to find the displacement when t is equal to 2. So the displacement will be 6 times 2 minus 2 squared plus 7, which is equal to 15. Then the total difference will be 15 minus 7, which is equal to 8. Questions A2, we're going to find the total distance traveled by the particle in the first 9 seconds. We know that the particles move in the opposite directions at t equal to 3. So let us find what is S3. So it will be 6 times 3 minus 3 squared plus 7, which is equal to 16. So the distance traveled by the particles from t equal to 0 to t equal to 3 will be 16 minus 7, which is 9. From t equal to 3 onwards, the particles is moving to the left-hand side. So here we want to find the positions of the particles at t equal to 9. So S is equal to 6 times 9 minus 9 squared plus 7, which is equal to negative 20. This means the particles is at 20 meters to the left-hand side of the fixed point O at t equal to 9. So from the fixed point O to here, the distance traveled will be 16. And the distance for this part, it will be equal to 20. Then the total distance will be 9 plus 16 plus 20, which is equal to 45. Questions B. Find the distance in meter traveled by the particle at this 7 seconds. At this 7 seconds mean it is from the 6 seconds to the 7 seconds. And from the number lines here, we know that the particles is moving to the left at the 6 to the 7 seconds. So first we're going to find the position of the particles when t is equal to 6. Then the displacement is equal to 6 times 6 minus 6 squared plus 7, which is equal to 7. This means at the 6 seconds, the particles is 7 meters to the right of the fixed points O. Next, we're going to find the position when the particles at t equal to 7. Then S is equal to 6 times 7 minus 7 squared plus 7, which is equal to 0. Which means the particles is at fixed point O when t equal to 7. So here will be the distance traveled by the particles at the 7 seconds. Then its total distance will equal to 7 meters.